Welcome to qnawire.
Okay, so we're doing chapter 18, problem 47 here. So it says a very small amount of hydrogen gas is released into the air. If the air is at 1 atmosphere and T is 15 degrees Celsius, estimate the mean free path for hydrogen for a H2 molecule. Okay, so what assumptions did you make? So for this molecule in air, we want to first compare the RMS speed of the hydrogen molecule to the speed of the air to see what kind of assumptions we can even make in the first place. So let's do that. So VRMS for H2 over VRMS for air. And this is given as the inverse of their relation of their molar masses, as we've done in problems before. And the molar mass for air is roughly 29 grams per mole. And the molar mass of hydrogen 2 is obviously 2 grams per mole. And this comes out to being 3.8. So what that means is the VRMS for H2 is roughly 4 times as fast as for air. So from that, let's write down some assumptions. So first, let's use the approximation, the stationary target approximation. So air is stationary. That's one approximation we're going to use. We're also going to assume that the intermolecular distance for a collision would be the sum of the hydrogen and radius air molecules. So the collision distance is RH plus R air. That's one assumption we're going to make. And we also assume that the radius of hydrogen, we're going to assume that this is roughly 1 angstrom, which is about the same, or the radius of H2 is roughly 1 angstrom, because the radius of hydrogen atom itself is roughly 1 angstrom. Okay, so these are the assumptions we're going to make now. And we know, so this helped us make the assumptions. These are what assumptions we're going to make. So we know that the equation we're going to use here is given in roughly equation 1810A. So we need to use the ratio of the velocities, so that's 4 over 4 pi r collision squared over times n over v. So these 4 cancels out. We can know that immediately. We also know that P equals N kBt over V, or N over V equaling P over kBt. So let's plug that in, and let's also plug our R collision in. So this now becomes Ln, the mean free path is 1 over pi. We have RH2 squared plus plus R air, all of that squared, quantity squared, okay? And then times P over kBt, or kBt over pi P RH plus R air squared. Cool. So now we know everything we need to know to calculate the mean free path, and that is 1.38 times 10 to the negative 23 joules per Kelvin times 288 Kelvin, all over 1.013 times 10 to the 5 pascals times pi times. Okay, so RH2 is roughly 1 angstrom, so this is 1, and R air we did in the previous problem 71. You can look back at that. Oh, and problem 45. So this was given as, we did 1.5 angstroms. So 1 plus 1.5 all times 10 to the negative 10 meters, and that's squared. Cool. So that's everything. We just need to plug all that in the calculator. And this comes out to being 1.998 times 10 to the negative 7 meters, or roughly 2 times 10 to the negative 7 meters. Awesome.